Alright, well, let's talk about exponents today. I want to start actually with a brief history of exponents and kind of tell you kind of the story of how they got started. It all started with a man named Nicole Oresme, alright, and he used the concepts of exponents, but he didn't use this notation that we use today. He actually put the two numbers next to each other and didn't use the raised exponent, which I'll show you in a little bit. Then came Nicolas Chuquet. He used exponents with the raised notation, and but he didn't use them the same way you use them, and so nobody really remembers his name as much. Then came Pierre Herjon. All right, he was a French guy who used the same type of notation as Nicole did earlier, but again, we don't use that notation, so you're not going to remember his name much as well. James Hume, so close to being famous for the creator of the exponent notation, but he used Roman numerals. And who wants to use Roman numerals? So we don't remember his name as well. But René Descartes, we remember him for the creator of exponents. He also did lots of other things that you will learn throughout your math lessons. But René Descartes is the creator of what we now know as exponents. Here's another picture of him. You can see he obviously liked this outfit, and the goatee is a little bit thicker over here. All right, so let's get started inside the math. All right, so how are exponents even helpful, and why do these men even bother with them? Well, these men did math for a living, so they were doing lots of multiplying, adding, and stuff. And exponents help us with multiplication. What exponents help us with is instead of writing this as 5 times 5 times 5, it was able for them to be able to write it much shorter and write it as 5 to the third power. This is 5 multiplied 3 times. Alright? So this is not 5 times 3, but it's 5 times 5 times 5. Alright? So how would we write this? 6 times 6 times 6 times 6 times 6 times 6 times 6. Imagine if you're writing lots of math journals and you had to write this 3 or 4 times. Well, it's a lot easier to say, well, I'm writing 6. 1, 2, 3, 4, 5, 6, 7 times, and so I can write that as 6 to the 7th power. So this is how we write in exponent form, and this is why it can be helpful. And why these men bother with them? Because they did not want to keep writing down these type of things over and over and over again. But they could write it much shorter this way. So I'm sure you guys will appreciate that to a certain degree. So 7 to the 4th. This is not equal to 28. This is equal to 7 times 7 times 7 times 7. As we solve exponents, I want to make sure that you write them down this way. First step, write down how many times we're multiplying that number. Then we can multiply them all out. So 7 times 7, that's 49 times 7 times 7. 49 times 7, that's 63. Carry it. 28, 34. So that's 343 times 7. And 343 times 7, 21. 28, 30. 21, 34. So 3,401. 7 to the 4th power. So that's how we solve it. Write down the number. This is called my base here. So write down your base. This is how many times you're multiplying your base. That's your exponent. And when I use the word raised notation, this is how it's raised. Exponent kind of comes from a Latin word. It kind of means weird or awkward because no one wrote down numbers like this before the exponent. It's kind of this awkward place or this weird place. So that's how we can remember exponent. And that tells me how many times do I multiply it out. Let's do another problem to show you. 3 to the 3rd power. So that means I'm multiplying 3 times 3 times 3. 3, my base, 3 times. 3 times 3 is 9, times 3 is 27. So 27 is my answer. How about 3 squared? Well, that's equal to 3 times 3, which is 9. Or we have 8 to the 4th power. That's equal to 8 times 8 times 8 times 8. Well, 8 times 8, that is 64. 64 times 8, 32, 48, 51. That's 500 and 12 times 8, and 5, 12 times 8, 16, 9, 40. So 4,096 is the answer. Do not answer it as 32. A lot of times people want to go 8 times 4. If I wanted 8 times 4, I'd write down 8 times 4. But we'll use this exponent notation, this weird notation, to write it down like this. So 4,096 is my answer. So if you have any questions about this, feel free to ask. Other ways we can use exponent notation. We can use it even with negative numbers. So this is negative 5 times negative 5 times negative 5. The way we have to write this down is negative 5 to the third power. Make sure you have those parentheses. Those parentheses are important. So make sure you have those. We can also use it here again. Negative 7 to the fourth would be negative 7 times negative 7 times negative 7 times negative 7. So would this answer be positive or negative? Well, this answer would be positive. I have 4 different negatives multiplied together, so it's going to give me a positive number. And that means 7 times 7 is 49. So 49 times 7, 63, 343. So 343 times 7 is, we did this one earlier, I believe, 21, 0, 30, 21, 24. So 2,401. And it's again positive because I have 4 different ones. My answer would be negative here because I have 3 different ones. That's why the parentheses are important. If we don't have the parentheses, it always makes it negative. Another thing we can use them for is exponents, is variables. And so we can put variables together. And so we can see a 2 times A times B times A times B. Well, I can use the commutative property to flip these two. You use the commutative property times A times A times B times B. You see I'm multiplying 2 A's together. So instead of writing A times A, I can write A to the second power times B to the second power. And I'm done. So that's another reason we can use exponents. And that's going to be a reason that we use a lot of exponents is for variables. The last thing that we use them is in PEMDAS, or order of operation. Let me remind you where it's at. First parentheses, exponents, multiplication, division, addition, subtraction. So first we do the parentheses. So for 3 plus 2, that's 5. Then we do the exponents. So that's 4 times 25. And then we get 100. So exponents comes after the parentheses before the multiplication and division. So that's what we use exponents for. If you have any questions, feel free to give me a call.